Okay, welcome to week 2 of the online SAT course. Today we're going to look at two major things. We're going to talk about working with a calculator, and then we're going to talk about some strategies for the SAT. Again, we're still in the introductory phase of this course. So to start, let's take a look at calculator problems as we go through these. So, the first thing we want to think about to ourselves here is this. Is the calculator always right? Is the calculator always right? And a lot of you are going to say, sure it is. It's a calculator. That's why we invented it, right? So we can work some math problems out quicker. And that makes sense. It's logical. But let's take a thought for a second. If you're asked to determine what the value of, let's say, negative 2 squared is, and everybody will say, okay, negative 2 squared is negative 2 times negative 2, which is positive 4. Sure, I agree. Negative 2 squared is positive 4. Now, I get the comment a lot that, well, I typed in my calculator negative 2 squared, and I got negative 4, Mr. Howell. How come it's negative 4? You're getting positive 4. And clearly we know it's positive 4 because we have this negative times this negative yielding a positive answer. So it's common sense that it's positive, but the calculator tells you it's negative. And I've seen this over and over again. This is a very simple example just to show you when the calculator is not always right. Now, the calculator is not incorrect in that sense, but we do have to consider the simple fact that if you input something incorrectly, you're going to get the wrong answer out. I know Mr. Malachek has a saying that some of you heard, garbage in, garbage out. So, back to this example here. Again, if we have something like we want to input negative 2 and we want to square it, the issue that I notice right away is a lot of students go ahead and they type it in, they type negative 2 squared. Now, everybody thinks that means you're squaring negative 2. But what this really means is the following. It means the opposite of 2 squared. So this will do 2 squared first, and then it will take the opposite of it. Again, remember, PEMDAS. So the calculator, what it actually will do is, it will do the exponent part first, and then it will multiply it by this negative sign, which would make, yeah, this is 4, and then it's going to put the opposite of out here. So your answer you would get would be negative 4, which we know is not correct. The answer should be positive 4. Well, let's take a look at the difference. Now this up here says, take negative 2 and square it. Again, the last problem, if you input it in this fashion, says, do the opposite of 2 squared. So take the opposite, or the negative value of 4, which again yields negative 4 over here, which is not correct. But looking at it the other way, we say, okay, in parentheses, this really means take negative 2 and square it. So that's just a simple example of where you could go wrong if you put garbage into the calculator. Again, remember, you have to have your parentheses always correct in a calculator. Now, the simplest way always to check parentheses when it comes to long equations is to see however many open parentheses you have the same amount of closed parentheses. But for this example here we're going to start with, we're just going to simply look at the example with negatives. So, again, if I wanted to do negative 3 squared, I need to start with parentheses, negative 3, close parentheses, and then I would have to square it after that. Then I hit my square key. And clearly I can see that, yes, it's 9. But again, if you just simply type in negative 3 squared here, you're going to see that you have negative 9. This is not correct by any means. Again, this is doing the opposite of 3 squared, whereas this is saying negative 3 squared. Two completely different things, even though they look the same. So remember, if you type something wrong in the calculator, it's going to give you the wrong answer in the sense of the problem that you're looking at. This is the correct answer according to the calculator, because the calculator is reading it again as opposite of, whereas we want to read it as negative 3 squared. So you're going to see that you're going to have some sort of argument between what you think the answer is and what the calculator is if you're not inputting it correctly. It always comes back to two things. First, common sense. Always use your common sense. If you're squaring a negative number, it should be positive, no matter what. Any negative squared, doesn't matter what the number is positive. So right away, the second line should say, okay, there's something wrong here. And secondly, always use PEMDAS. Always use PEMDAS. Here, this is saying, okay, well, there's parentheses, then I'll look at the exponent. So it's going to evaluate the parentheses first, which is negative 3, and then it's going to square it. Whereas here, it's going to do parentheses, but again, there's no parentheses here. So then after parentheses from PEMDAS, we know to go to exponent. So this problem will then do this portion first. Then it will use the multiplication. So it will take the negative, which it thinks of as a negative 1, and it will multiply this by whatever this is, which is 9. Well, negative 1 times 9 is what gives you that negative 9. So remember, if you don't have PEMDAS in mind, sometimes you can make mistakes along the way. Again, a simple example to start with, you need to enter the correct things into the calculator in order to get the correct answer out. Continuing this, let's take a look at some simple examples. First, as you can see, the first line here, we have PEMDAS. If an expression asks the quantity here, 7 minus 3 quantity squared, minus 4 divided by 2, times 6 plus 1. Okay, looking at this problem, it might get a little bit confusing. Well, parentheses first. So we first evaluate this portion here, and we see that that is simply 4. Okay, well that's 4 squared minus 4 divided by 2 times 6 plus 1. Now, PEMDAS next tells me to do exponents, so then I make that a 16. So my next line is 16 minus 4 over 2 times 6 plus 1. Notice I'm saying it all in one line because I don't know what to do first until I consider PEMDAS. Now, PEMDAS tells me, okay, I've done parentheses, I've done exponent. Those two are done. Now I have to look at multiplication next. Well, let's see. Okay, well, multiplication and division, they're actually grouped. And most people forget that. So when you're looking at PEMDAS, here's what you're really looking at. You're really grouping these. So what this tells me is that once I finish parentheses and exponents, I go on to multiplication and division, but I perform the operations in the order they appear from left to right. For example, here's a division, here's a multiplication. Which one comes first? Well, the division shows up first if I'm reading from left to right. As I move over, I see, okay, there's subtraction, I don't care about it. Oh, there's division. I stop, and I do that first. So my next line will say 16 minus. Then I think of this as if it's in parentheses, because division is next. I divide those two. 4 divided by 2 is still 2. I carried out everything else, and now I continue. Continuing this problem from left to right again. Well, there we go. We see that, again, subtraction I ignore for now. There's multiplication. So I stop and look at this now. Well, 2 times 6 is simply 12. So you're going to have 16 minus 12 plus 1 now. At this point in time, you can just combine like terms and think about subtraction and addition. But remember, subtraction and addition is also grouped. So it doesn't matter whether addition or subtraction comes first in the acronym, but what really matters is where it shows up in the actual evaluation. And here we're going to see that it's really 16 minus 12. And then we're going to add 1 to that. So 16 minus 12 is really 4. And then we carry over the plus 1. 4 plus 1 is 5. And we can see that our answer over here got verified from the calculator. Now, the calculator will always perform PEMDAS in the order it sees it. So if you enter into the calculator the exact same way you see it on your page, you shouldn't have any issues with it. Again, parentheses are key here. Make sure your parentheses exist. Because without the parentheses here, this would look like 7 minus 3 squared. Minus 4 divided by 2 times 6 plus 1. Again, if you forget your parentheses, that looks like 7 minus 3 squared. As opposed to quantity, 7 minus 3 squared. So remember your parentheses. Next, let's take a look at square roots, cube roots, and any powers in general. So the first example to take a look at is square root of 151. Well, the square root of 151, you might say to yourself, okay, that's going to be a number between 12 and 13, because I know that 144 square root is going to give me 12. 169 under the square root is going to give me 13. Now, I'm only looking at the positive roots right now. But again, I'm looking at 151. So that is somewhere between 144 and 169. Well, you might say, how far between? And later on, when you go on to calculus, you're going to learn how you can estimate the exact value. And using calculus techniques, you can actually get almost to 3 decimal spots accurate. So you can figure this out. But again, that's with a calculus technique. For now, let's take a look at our calculator and see what we can do. So again, we want the square root of 151. We open up our calculator, clear out whatever's in here for now. Now, I might say, okay, well, where's the square root key? If anybody's curious, you want to press second first, and then press this key right here. And you're going to see this little square root symbol there. Again, second, and then we see the x squared, there's a square root symbol. So to do that, let's go ahead and do it. We press the second key. It just makes the arrow show up here. The arrow that shows up here, let's see if that works better when we pull this. There we go. The arrow that shows up right here just indicates to me that I'm on the second command. So anything I press from this point on is going to be any of these blue symbols, any of the blue symbols you see, because I'm looking at the second command. The second refers to all the blue symbols. So again, I've already pressed second. Now I want to press the square root key. Well, I see the square root key is right above x squared, so I'm going to press the x squared button. Now, it brings up a square root. Whenever you bring up a square root, it's going to open a parentheses. So when you open parentheses, you got to remember to close the parentheses. So I type in 1, 5, 1, and close. Now, in this case, for a simple number, it wouldn't matter if you closed really. But I recommend you do so to develop the habit of however many parentheses are open, one open, you have that many closed. So wherever you see an open, you should also see a closed. Now again, I just simply press enter next, which is in the bottom right corner, and I see that my answer is 12.288, etc., etc. Now, on the SAT exam, sometimes multiple choice answers will be left in radical form. So you don't have to estimate. Sometimes they'll have values that you have to estimate. So if you got your answer and it was radical 151, and your choices were choices, for example, let's say our choices for A, B, C, D, and E were not radicals. They were right away, you saw that your choices were 7, 8.2, 12.3, 9.1, and negative 10. Let's say those are my choices in the problem. Clearly, radical 151 isn't a choice, so you would have to estimate. And this is 12.288888 or 882.057. Now, if I look at my decimals, I can see that I was rounded to the nearest tenth for the most exact number here. So I might have to think about, okay, that's an 8, which means round this up, so it rounds to 12.3. Choice C is my answer. Now, if you have radicals in all the answers, and you get a decimal as your answer, you might have to go backwards. So let's say that your answer for this problem turns out to be, let's say, 7.1. Now, what if all the choices were the following? Say your choices were radical 71, radical 82, radical 35, square root 27, and then the square root of negative 8. Now, clearly, choice E is out right away, because as we know from Algebra 2, a negative under the radical means it's imaginary. This is a real number, thus choice E is automatically ruled out. Next, a lot of people look at choice A when they see this answer, and they say, okay, well, radical 71, that looks close to 7.1, so that must be close to my answer. And a lot of people would choose choice A. If you evaluate the square root of 71, you're going to see that it's actually 8 point something. Again, 64 radical would give you 8, 81 radical would give you 9. So radical 71 will be somewhere in between there. So this is really a value like 8 point something something something. Now, I don't care what those decimals are right now, because I can clearly see that if I look at my answer, it was 7.1. 7.1 is not the same as 8 and change. So choice A is now out. Looking at the rest of the choices here, we're going to see, oh, hold on a second, sorry. This value here should have been radical 50. Sorry, not radical 27. Now, if I look at choices B, C, and D here, I'm going to see that choice B is radical 82. Well, radical 81 we said was 9. So this is going to be 9 point something something something. That's out also. Radical 35 is a little bit less than radical 36. And we know that radical 36 is really 6. So radical 35 might be like 5 point something something something. So that's also out. So by default, we know already that our answer is going to be choice D. And we can take a look and say, okay, that's square root of 50. I want to know, is 7.1 close to square root of 50? So I might want to just go second square root, type in the 50, hit enter, and I'm going to see that if I round this, this would round to 7.1. Again, we see the 7.07. The 7 will round to 0 to a 1. So again, our answer is 7.1 here. Now, that wasn't a choice as your choices, but radical 50 was your choice. You would make that selection. Again, this is just a tool that you can use. Let's go on to our third topic here. If you don't have a simple square root and you have something to a power, you have to remember, if we're looking at something like a power here, it's 130 to the 2/3 power. So take a look at the snapshot here. It's not 130 to the 2/3 power, because what this tells me is this. The calculator would say, okay, do 130 squared, and then divide that answer by 3. But clearly this problem asks for 130 to the 2/3. So when you calculate this, you're going to notice here that if you did 130 to the 2/3, oops, let's go back and fix that, 2/3. you're going to see an answer of around 26. Now, what if you did 130, but you forgot the parentheses to the 2/3? Now you're going to say again, it's really 130 squared, and then it divides the answer by 3. So here, if I hit enter now, look at the difference in that answer. I mean, it's clear. If I say 2/3 power, as opposed to doing 130 squared, and then dividing it by 3. I mean, we're talking 5,000 versus 26. Big orders of magnitude differences, okay? So again, our answers are very important to us, but if they don't make sense, we have to think about why they don't make sense. So again, why did this one make sense? Because we're missing the 2/3 here. We're missing the 2/3 as a fraction. In Algebra 2, we're going to get to the idea of rational exponents, where the exponents have fractional exponents. So for an example, to continue this, what if you were asked, and we'll go over this when we get later in the year for Algebra 2, if you were asked to do the 4th root of, let's say, 7 to the 3rd. Now, a lot of people might say, okay, I got to do 7 to the 3rd, and then I got to figure out how to do this 4th root thing. Well, what this really means is 7 to the 3/4. And we're going to go over this later in the year, but you should have seen this in Algebra 1. The index is really the denominator in the exponent, and the power is really the numerator in the exponent. Now, this can also be written as the 4th root of 7 to the 3rd. These are the same things. Again, these are interchangeable. The 3rd could go on the inside or on the outside. The 3rd could go on the inside or the outside. But it's very important that you notice that you are really doing 7 to the 3/4 power. So if you're entering this calculator, you have to press 7, caret, parentheses, 3/4, close parentheses. Remember, it's to the 3/4 power. We go ahead and do that. Let's take a look on our calculator now. 7 to the 3/4. Pull up our calculator. 7, caret, parentheses, 3/4. Oops, I missed the parentheses, and clearly would have been a mistake. Let's go back, parentheses, 3/4. Where am I getting the slash, you might ask? The slash is just the division sign, even though it looks like it's not. Again, this division sign right here really means slash. This division sign and this slash are interchangeable. They're the same thing. Now, evaluating this value, hit enter, and you're going to see that you get 4.3. Well, let's take a look and think about this logically. What this is telling me to do, again, as we said before, was really the 4th root of 7 to the 3rd power. So you could simply do the 4th root of 7. Now, you might say, well, how do I do the 4th root of 7? Well, the 4th root of 7 is really, 7 to the 1/4. Again, because my power is now a 1. So the power becomes a 1 here. So if I want to do the 4th root of 7, and then I want to raise it to the 3rd power, so here I want to say, okay, myself, I want to do the 4th root of 7, so 7, and I want the 4th root. Okay, and I want to raise that answer to the 3rd power. And I take a look and see that if I do 7 to the 1/4 and then raise my answer to the 3rd, I get 4.3. Or 7 to the 3/4 is still 4.3. No difference in your answers, but different techniques on how to do that. I hope everybody noticed already, though, I used the answer function. Let's go ahead and take a look at that now. Let's say I had a problem, and the problem asked me, let me clear my calculator real quick, and the problem asked me, all right, I want to know the value of 2 times 3 plus 4. Now, most of you are going to say, yeah, that's 10. Obviously, Mr. Howell. 2 times 3 is 6. 6 plus 4 is 10. I agree. But all I want to show you now is how you can input this in the calculator using the answer key. So, if I wanted to actually do this on a calculator, I did 2 times 3. And I get an answer, and I say, okay, that's 6. And now I want to add 4 to that. If you simply press the plus key now, it will take the previous answer automatically. So when I press plus, it automatically adds it to the last answer. Plus 4, sure, there's the 10 that we said. Now, another way to do this, let's say I wanted to take my answer. And let's say the problem now said the square root of 37 divided by 4 plus 8. Now, I want to take the square root of 37 divided by 4 and add 8 to that. All right, well, let's take a look. If I take the square root of 37, second square root of 37, then I want to divide that by 4. Just simply hit divide by 4. It takes the answer, divides it by 4. And then you want to add something like, what did I say, 8, I think? Add 8 to it. Plus 8 adds 8 to the previous answer. Now, if you keep doing this, you're going to notice you can use the answer key in other ways also. You can actually call up the answer. So if I want to call out the 9.5 and I want to square it, I can simply press square and it'll square the answer. But if I forget that, I can always go ahead and press second and then press the answer key down here to bring up the answer. Again, the answer key is second and then the negative symbol. This negative symbol here, if you press second and then hit negative, it'll bring up the previous answer. So once you've brought up that answer, say you want to then square it, again, press the square key, hit enter. Now, one thing I do want to point out, powers. Everybody uses the square key. I encourage you never to use it, actually. I encourage you to use the caret key. Now, the caret key just means raise it to a power. And you're going to see the caret key is right here. It can be used for any power whatsoever, not just square. But a lot of people get confused. They realize, or they look and they say, okay, well, I need to do this to the fourth power. I don't see a fourth power, but you can always use the caret. So the caret is always used whenever your exponent is not 2, for example. So if you had 53 to the third power, 53 to the third, you want to hit caret and then 3, hit enter. Okay, again, there's no third power. There is a third power, but it's under math, and you got to go all the way through all these steps. Don't go ahead and do that, please. Don't even use this function here. This is like the nth root. Just remember that if you have a function like the fourth root, it's the same as raising it to the 1/4 power. Now, with that said, let's go on to the next thing. The pi symbol. Many people get confused about pi. Pi, again, is an estimation for the circumference over the diameter. When we think about pi, yes, pi is an exact value. But when we call it up in the calculator, it is not. It's estimating. So again, where is the pi key? The pi key is right here, next to the caret key. Well, take a look. If we look above the caret key, there it is. There's the pi symbol, which tells me I have to press second and then the caret. So if I want to bring up pi, say I want to know what the value of, say my answer was 12 pi. Okay, 12, I press 1, 2, second, and then press the caret, it'll bring up the pi. Now if I hit enter, I'm going to see that I have a value that's decimal. This is the estimation. Remember, let's say in this case, the problem said we had a circle, and we're finding the circumference if the diameter, in this case, would be just 12. It says find the circumference. Well, the circumference is 2 pi r. If the diameter is 12, then the radius just is 6. So the circumference is 2 times pi times 6. Well, 2 times 6 gives me the 12, so my answer is 12 pi. Well, then you might say, okay, that's exact, and that is. I know if I had centimeters, let's make believe these were centimeters, my answers would just be centimeters squared. So 12 pi centimeters squared. Again, oops, not squared, linear, we're doing circumference with area squared. We're looking at 12 pi centimeters here. So for 12 pi centimeters, that might not show up as a choice. If that doesn't show up as a choice, then you might notice and look at your choices and see that, okay, well, one of your choices might have been like 37.7 centimeters. Well, that's the same thing according to the SAT. I know it's an estimation, and we always make sure that we write it's an approximation. Again, the circumference is approximately 37.7 centimeters, even though the real value, as we said a second ago, is 12 pi centimeters. Again, it's good to know how to use the pi key when you need to estimate what the value is in terms of pi. Now, keep this in mind, though, at the same time, a lot of the answers in the SAT leave answers in terms of pi. Okay, and we'll get to those kinds of problems when we see them. So if you have an answer that has all pi's in the answer, you might not want to do this. You might want to leave your answer like pi. Let's go ahead and take a look at a simple thing like converting from a decimal to a fraction. So, let's say this is your final answer for a problem, 400 over 2,000, and maybe it's a grid in. Okay, you go to grid in, and then you notice to yourself, well, there's only really 4 grid in boxes and all these other, bubbles you have to fill in. So I know I can fill in 400 over 2,000. Well, many of you are going to notice, sure, just reduce. I agree. Reduce these, you get 4 over 20. You can grid in 4 over 20. You can always realize this is also 1 out of 5. So you can grid in 1/5. Now, say you forgot how to reduce or you had a brain fart and you want to think to yourself, okay, I don't really know what that is. Well, you know what? Let's go to our handy dandy calculator, take a look. My question was 400 over 2,000. So I go ahead, type in 400 divided by 2,000. When I get my result here, I'm going to see that, yes, it's just 0.2. The calculator will always default to give you a decimal value here. Now, Let's say that, it's not a grid. If it's a grid in, sure, grid in point 2, you're done. But let's say it's multiple choice. And the choices are as follows. Your choices are 1/5, 2/5, 3/10, -2/3, and 1/9. Now, you forget how to do point 2. You forget what point 2 is as a fraction. Uh-oh, how do I do this? How do I know which one? Well, you could sit there and literally divide each thing. You could say, okay, 1 divided by 5, get an answer. 2 divided by 5, get a decimal. 3 divided by 5, 3 divided by 10, get a decimal. And go through these. And many of you should have these memorized. You should know almost all of these actually right away. The only tough one is the 9th one, but we'll show tricks about how to do that a little bit later. Now, if I want to convert point 2 to a fraction, and again, I'm looking to see which of these answers is my possible answer. If I look here and I see that point 2 is my answer, okay, well now I want to convert that to a fraction. So you press math and take a look under math immediately. Number 1 means convert to a fraction. Number 2 would mean convert it to a decimal, but it's already a decimal, so you don't have to do that. So all you have to do is press enter. Now, it will say, take the last answer and convert it to a fraction. Well, pretty simple, right? Hit enter. See what happens here. When you hit enter, oh, there it is, 1/5. And if you remember from a minute ago, our choice A was 1/5. So yes, point 2, many of you would make the statement that, yeah, this is 2/10, because that's how I would say that. But 2/10 simply reduces to 1/5. Okay, I don't encourage you to use your calculator for this. If you can do it in your head, I encourage you to do it in your head. But in the case that you forget and you want to go ahead and take it as a safety precaution, go ahead and do that. That's converting to decimal to a fraction. Okay, performing an operation on an answer. So, we have a problem that says, if 2.5x equals 7, find double x. Okay, well, I know 2.5x is equal to 7, so I have to start by dividing by 2.5, divide by 2.5. You're going to get x equals 2.8. Again, 7 over 2.5, that's this portion right here, is simply 2.8. But now I want to say, okay, remember, I have to answer the question being asked. The question does not ask for x, but it asks for double x. So now you have to double the value of x. So double 2.8. Well, how do you do that? You take your answer and times it by 2. And you'll see that your answer is 5.6. Now, what you're going to notice next is that, okay, I don't really have to go through all this step, or to go through all of these steps and do this all on paper, so I want to just simply use my calculator. Please feel free to go ahead and do that. You don't have to show all the work. Just use your calculator. Right away, divide by 2.5, then realize, okay, I need double x, then multiply by 2. So we took the 7, divided by 2.5, and then took the answer and doubled it. You don't need to show your work on the SAT. Again, you get no credit for work on the SAT. So anything that you want to do in your head or immediately in the calculator, feel free if it saves you time. It's always about saving time and getting the correct answer. All right, let's take a look at our next one. If we want to use a graphing function to evaluate a function, so this problem says, if f of x equals 4x squared plus 3, find f of negative 3. What you're going to notice here, many of you are going to say, Mr. Howell, you're crazy. I'm not going to use a calculator to do this. Sure, I agree. 4 times negative 3 squared plus 3. 4 by 9 plus 3 is 36, plus 3 is 39. Done. Answer. And I agree. I would just, evaluate your exponent, multiply the 4 and 9, add the 3, and you get an answer. If it was something a little bit more complex, say you had a function f of x and it equaled, let's say, x to the 5th plus 2x to the 4th minus 3x squared plus 5x minus 1. You don't want to plug in that value, especially if it's negative, into all those, because there's a lot of room for error. So what do? You take this whole function and just plug it into your graph. You can plug it into your calculator, sorry, the whole function, including the negative one at the end here. You can plug this into your calculator. So, for simplicity, we're going to use this example here and figure out f of negative 3. So let's go ahead and do that. Again, it's 4x squared plus 3. I go over to my calculator. I clear out my table. It doesn't matter. I don't have to actually clear it. I go to y equals. Where is y equals? Well, that's up here. So I'm simply going to just press that button once. And again, I'm doing 4x squared plus 3. So I go to y equals. I type in 4. Where's x on here? Well, here's x right up here above f's. So I want to take a look here, and there's my x value. Again, even if it's w, even if the variable is, you know, j or l or u, it doesn't matter. Whatever the x value is, so if it was like f of w equals w squared minus 4, and you want to plug that in the calculator, think of it as f of x equals x squared minus 4. And again, you're going to use the x. The x comes about from this key right here. Again, from that key right there. So we want to type in 4x squared plus 3. So we then press the x command. We press the caret 2. I'm squaring this way. You can square with the square key. It doesn't matter. And then plus 3. Again, I don't need a parenthesis in my exponent because the exponent is simply 2. If it was like 4x to the 2/3, then I would need a parenthesis around the 2/3. But since it's just a 2, I don't need the parenthesis there. There's no fraction involved. Now, once you've got that in your y equals, you can then just use your table. Now, the steps for a table are simple. Many of you might have tables that already have numbers in them. And the reason being is because of this. A lot of calculators default to auto. And what auto means is this. Automatically, let me get that so it's flashing correctly. Anyway, automatically, it's not showing up, but automatically choose the independent variable. So the calculator picks values here. Well, it starts at 0 because the table start says 0. So it's going to start at 0. And what do you notice it goes up by? It goes up by 1 every single time because the table interval value is 1. Now, those things mean nothing. All I want you to do is this. Change your independent settings to ask so that you can ask the calculator this value so that it can automatically give you the y value. So go ahead, if you haven't done this already in my class, go down. So it doesn't matter what the table starting and the table increments are. Go down to independent, meaning the x value, the independent variable. Change that to ask. So now if you look at your table, and you can see on my table already here, the table has disappeared. Because we're going to ask values. We're going to plug in values like 0, or 1, or 2, or 7, or 35. And it's going to give us the values of y, whatever they turn out to be. Okay, whatever these numbers are, it will show. Because y is automatically being chosen. Whereas x, you are asking the calculator what to pick. So let's go ahead and put in -3 now. Well, how do you do that? I don't see anything on here. So press second, then press the table button. The table button is the second command above graph right here. So go ahead, you already pressed second. Go ahead and press the graph key, and you see your table pop up. Well, I want to know the value -3. -3, again, the negative symbol is down here. This is subtraction over here. Okay? Again, this is negative. This is subtraction. They are different keys. Again, the negative one is at the bottom. So I want to input -3. I go ahead, press -3. I hit enter, and I see 39. Just like we got when we did it by ourselves. So again, just to check our answer, go back, take a look. All these steps are laid out. This is what I went through for everything. We see that we get 3, and we get, -3 is our input, and our output is 39. Again, our function output is positive 39 here. The same answer you would get as if you used your own direct evaluation. Now, if you remember from Algebra 2 now, we talk about something called the synthetic table. If you're interested, you can use that as well. What I do want you to remember is for the synthetic table, though, that you have to have your 0 placeholders. So if you want to go back and think about the synthetic table now from Algebra 2, and you're doing the same problem, and you want to find out the value here, your synthetic table would look like this. 4, 0, 3. Because again, we're missing the x term. There's 0 x's there. We start with x squared, we're missing x, and we have a 3. Plug in the -3. Bring down the 4. This gives you -12. -12 and 0 is -12. This gives you 36 when you multiply these two next. 36 and 3 is 39. So you get the same answer, but it's 3 different ways. Again, using your table function on the calculator, using direct evaluation like we did the first time, or using synthetic substitution like we just showed now with the synthetic table. All right. Using the graphing function to find the roots of an equation, the roots. This is very important. It is used very widely. You can always use this function to solve any sort of function or any sort of equation. So let's start with an example where we might be given, let's say, the exact value of x in the following equation. So looking at this one here, there are really two ways to do this. One way is to start and say to yourself, okay, if I can move everything over, I think of it as if it's a quadratic, and this is clearly going to look like a parabola. It's going to open upward since the a value is positive in the front. Now, I want to think to myself, the answers to this are wherever it crosses the axis. So one might be negative, one might be positive. They might be over here. It might be over here. It might be down over here. It could be several different things. But what we're going to do is try and use the root function. So, in order to do this, we want to think to ourselves, whenever you're using the root function, you need to have a 0 on this hand side. So once you get a 0, now this is like your y equals. So you go ahead into your y equals, and you plug that into your y1. Once you've plugged that into y1, we're going to say to ourselves, okay, we might want to zoom in and look at the roots, or I can just simply graph this. So we've got x squared minus 1.5x minus 7. So I go to my y1, I clear it out. I've got x squared minus 1.5x, and I think it was minus 7. Let me just check to make sure. Yes, minus 7 again. So I've got x squared minus 1.5x minus 7. Now, once I've plotted that, I can simply start by just hitting graph. And what I'm going to notice here is that I'll see I have a pretty simple graph. Now, I want to figure out the roots or the solutions to the equation. The roots or the solution are always where it crosses the x-axis. So clearly this one is between, let's say, 1, 2, 3, 4, somewhere between 3 and 4. This one is right around negative 2. It's approximately negative 2, but we don't know what the value is. And I'll tell you now, it's not going to be a whole number. It might sometimes, okay, but a lot of these kinds of problems are going to be decimal values. Now, in order to figure out what that actual value is, we have to use our root command. Now, to do the root command, let's go through this process. Everybody. Press second, then press the trace key up top. And you'll see along the top, you see the trace key is the fourth one in. And above that, you'll see calculate, or C-A-L-C for calc. And it means calculate. We want to find the roots. If you remember, in Algebra 2, we talk about the roots being the same thing as the zeros of the function. So we're pressing number 2 now. So either you can go ahead and type number 2 and just choose choice 2, or go down and press enter. Now, for number 2 here, we're going to see that it says left bound. All this means is as follows. Give it a guess on the left side of one of the roots. Then it's going to say right bound. Well, if I pick a right bound over here, it's going to not know which root to pick. It could pick either of them. So once you pick your left bound over here, your right bound needs to be somewhere over here, or somewhere over here, so that there's only one answer between the left wall and the right wall. You're pretty much putting up a wall here and putting up a wall somewhere over here and telling the calculator, search for an x-intercept in here. And it's going to search and find this x-intercept. If you put up the incorrect walls, then it's not going to know which one to pick. So let's go ahead and do that. So for a left bound, I might choose something like -4. So -4, enter. That'll put up a wall again. 1, 2, 3, 4. That'll put up a wall right here. That'll put up a wall there. And the next choice, I might choose -1. So it puts up a wall right around it, and then it will choose. So for the right bound, let's go ahead and choose -1. So -1, enter. And then it says guess. You don't really have to guess. You can choose -2 to guess. But if your bounds are correct, you don't have to guess ever. But I'm going to do it just for the fun of it. So -2 is my guess. Oh, and it turns out my exact value is -2 here. Again, this exact value turns out to be -2. Now, that is one of your answers. Well, where's the other answer? Here it is right here. Go through the exact same process on your own to figure out what the root is on the right-hand side. Again, when you give a left bound, though, your left bound might be now x equals 1 for the left bound. And for the right bound might be like x equals 5. And then from there, it'll choose the number between. If you want to take a look and check the answer. Okay, again, it's all the steps, how to do this. One of your answers is -2, and the other answer happened to be 3.5. Okay? Another way to solve the exact same problem. Another way to solve the exact same problem, and all problems for this sense. Whenever you're given an equation, you can simply put this in y1, you can put this in y2, and remember from Algebra 2, find the intersection. Because that's what this is saying. find the intersection location, and then look for the x-coordinate. So let's go ahead and do that to verify that we have the exact same answer. So we can see that for y1 it's just going to be x squared. y2 will be 1.5x plus 7. So let's go ahead and plug that into our calculator. y1 is now simply cleared out. It's just x squared. y2 was 1.5x plus 7. Now, if I graph these and I hit graph, I'm going to see that I have a parabola clearly, and then I have a linear function. And I know it's going to be a linear function because it said 1.5x plus 7. Now, you're going to say to yourself, well, I only see one intersection, Mr. Howell. Well, we got two answers last time. Well, the other intersection is off the graph. So now I have to think to myself, okay, I need to change my window settings. My window, excuse me, my window settings enable me to expand the graph. I can use the zoom function, but I recommend not using it. Use the window settings. So here's what I'm going to notice. Currently, my window goes from -10 to +10. And my window over here goes from +10 on the x and then a -10 on the x. So my bounds, again, my x min is -10. My x maximum is +10. My y minimum is -10. And my y maximum is +10. This is your standard graph, your -10 to 10 in both directions. Now, I want to go further up. I want to extend this graph upward. So I need to change my y max. I might want to make it like, I don't know, 20. And do I care about below the x-axis? No, because there's no intersections going on down here. So y min, I might want to make that like 0, or just something like -1. So let's go ahead to our window and take a look at our window settings. So, to change your window settings, simply press the key that says window, and you'll see it along the top. It's the second key along the top. So we press window. Now, the x min and max we didn't have to change. The XSCL means the x scale. Notice, all of your tick marks go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the bottom, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, the marker's off, 9 and 10. But you're going to have 10 tick marks because the scale goes by ones. Everyone is counting by 1. You could simply change the scale if you'd like to, and you can always mess around with that. For now, we're going to leave it. We want to change our y min to -1. We want to change our y max to +20. And what we're going to notice, and many of you can already see this, if you look at my graph, before you even hit graph, you'll see that now the graph looks much nicer because I have not just one intersection, but two. And remember, I had two answers to this problem. So let's go back, go to our graph, let's hit graph. We'll see that again clearly. We're going to have not just one, but two intersections. And remember, when you're solving an equation, the intersections are the solution. But it's important to remember that it's the intersection's x-coordinate. Because when we get the intersection, this intersection is not just an x value. It's some x value, comma, some y value. This is some x value, comma, some y value. It's the x values that are important whenever you're solving an equation. Whenever you're solving an equation. So let's go ahead and go through this process. So, again, we're calculating something. So press second and then calculate. Same command that earlier brought up the zero function. But now I want the intersect. So what you're going to see here is that I'm not really looking for just the zero function, but I really want to figure out what the intersect function is. So I go down to intersect now. If we can get there. Go down to intersect. Now it's going to say first curve question mark. It's just saying along the first curve, where is the intersection? So you're going to see that there's a flashing dot at the origin right now. Here's your flashing dot right here. Okay, so when you see that flashing dot right there, it's going to tell you that it's guessing that's the value. So either use your left or right keys, you can move it over. And you're going to see that the flashing dot keeps moving. Well, I want to go to the intersection, so I might want to go close to it. So go somewhere close to it, hit enter. Then it's going to say on the second curve. Well, the second curve is just this linear function. So it's already there pretty much, so just hit enter again. Now, it's going to then say to you, okay, guess a value. If you're in the area, you don't have to guess. Just hit enter one more time. When you hit enter that one last time, it will give you the intersection. Now, the intersection is -2 and 4. But clearly we said again, the x value is what's important. So this is the solution right here. And if you go back to the example, you're going to see that my solutions were -2 and +3.5. Well, this coordinate here is 3.5 for the x, and whatever the y turns out to be. Again, I don't care about the y value for these. They don't matter. So ignore the y values. They don't matter for these. It's the x values that matter. And you'll see that 2 and 3.5 are the intersections. So if we go back and take a look at our example, we take a look and see that we get the exact same answer whether or not we plug in the intersection command or the 0 command. -2 and 3.5 are still my answers. Okay. Next problem, solving simultaneous equations. If they are linear, this only works if equations are linear. What does linear mean? It just means that nothing is squared, nothing is cubic, or you don't have x times y or a times b. Now, with this problem, we want to go ahead and say, okay, we have a system of linear equations. And the problem says, find the value of a plus the value of b minus whatever the value of c is. So we have to put everything in standard form. Now, remember from standard form, this has a 1/2 a, this has a b over here. I need to move the b over, which gives me the negative b. Now, this equation is done. There's no c value, so there's no c. And there's no number, constant, so there's a 0 there. Next one, you've got 3 c's. That's going to be right here. We need to move the 4.5a over, which gives a negative 4.5a. There's no b's, and there's no constant numbers. That's done also. And then the last one says 10b plus 22 equals 7c. Well, 10b comes about right here. The 22 needs to be moved over here, so it becomes a negative 22. And the 7c has to be moved over here, which is a negative 7c. Again, this is a reiteration of what we've done in Algebra 2 already. So this should be familiar for everybody. Now, once you have your system of equations set up, go ahead and use your matrix function. Remember, from Algebra 2, this is simply a matrix. This is what these brackets are here. So, all you have to do is list your coefficients. So the 1/2, -1, 0, 0. 1/2, -1, 0, 0. Next line. -4.5, 0, 3, 0. -4.5, 0, 3, 0. And then the last line is 0, 10, -7, -22, or 0, 10, -7, -22. Now, you might be wondering, okay, well, how do I put this in a matrix? Well, we did it in Algebra 2, so this should be a bit of a reference for everybody, or a bit of a recall. So, if we want to use the matrix, the commands are all laid out here, but I'm going to go through them one at a time. The first thing you want to note is, what are the dimensions? The dimensions of any matrix are the amount of rows by the amount of columns. There are 3 rows here. 1, 2, 3. There are 4 columns. 1, 2, 3, 4. So it's a 3 by 4 matrix. That's the first thing to note. Now, after we do that, we have to go into our calculator and say, okay, what is a 3 by 4 matrix? How do I actually input it? So let's go ahead and do that. Opening up our calculator, we're going to see here. Let's quit out of this. We're done with our y equals. We just finished that already. I'm going to clear this stuff so it's not in the memory. Now, I want to use the matrix command. The matrix command, you're going to notice, is above the x to the -1. So I have to use my second key. Second, and then I have to press matrix. So I go ahead and do that. Second, and then I hit matrix. Now, you're going to notice on my calculator, there's already a 2 by 3 matrix set up. But I don't care about that. I'm going to overwrite it. So, in order to input a matrix into the calculator, you must go over to Edit. So we go over to Edit. Hit Enter. Now, whoops. Let's try that one more time. Second matrix, go over to Edit and hit Enter. Now, it's going to bring up the actual matrix and it's going to look like an input. And if you go back to our problem from a minute ago, we saw that this right here, this matrix was a 3 by 4. There were 3 rows, 1, 2, 3, and 4 columns. 1, 2, 3, 4. Again, 3 by 4. So I go into my calculator. I see it's 2 by 3. Okay, so type in 3, enter. Move over, 4, enter. Well, it looks like a 3 by 3 to me. I see that there's 1, 2, 3 looking columns, and it looks like 3 rows. But if you press the right arrow key, you will notice that it goes over to another column. So there really are 4 columns here. And at this point, I'm simply typing in my numbers. So I go back to my page, I look at my coefficients. I've got 1/2, -1, 0, 0. So I've got 1/2, enter, it'll convert to decimal. Negative, make sure you use the correct key, remembering that the negative is down here, people, down here. So -1 is the second number, and then it was 0, and then it was another 0. Then the second line, then I go to the second line. I'm going to notice here, the second line is -4.5, 030. So negative 4.5, enter, 0, enter, 3, enter, 0, enter. Third line, 0, 10, negative 7, negative 22. 0, 10. Forgot that one. Negative 7, negative 22. Negative 7 and negative 22. Now, you've input the matrix. You're kind of done with the problem. But we got to go back and say to ourselves, remember, and we've done this in class a lot, this really means the A column here. This really means the B column. This is the C column, and this is the constant. So this really like A's in all these, and then these are all really B's and C's, and then these are numbers. So when I get an answer, I'm going to see what to do with that. So just keep that in your memory. So in order to get an answer, or to figure out the values of A, B, and C, again, which is what we're trying to find, we bring up our calculator. Okay, we exit the matrix. You have got to exit the matrix. Press second and then press quit. Again, second quit is second and then hit the mode key where the quit is. That always brings you back to the home screen. Now, we want to do what's called row reduced echelon form. What you need to remember is this. If you want to solve a matrix and get the solutions, you have to think of that command. Row reduced echelon form. All it means is that you're going to see ones in all the pivots, or all the diagonals, and you're going to see some numbers over here as your answers. Okay? Again, we've done this before. So we press second, we press matrix, go over to math, go down or up, either way. I'm going to press down for now until you get to RREF. Now you notice, okay, there's just RF or just REF, but I want RREF, so I need to make sure I go down to the B command. So I have RREF. Hit enter. I want to do RREF of the matrix I just put in. So I go into my matrix again. I press enter here, close your parentheses, hit enter once more, and take a look. It's exactly what we wanted to see. And if you remember, there's really A's here, B's, C's, and then these are my constants. So if I wrote the first row out as an equation, it would say 1A plus 0B plus 0C equals 4. Or, since these are zeros, they drop off. Or simply 1A is 4, which tells me again, A is 4. Again, so this is the A value. This turned out to be whatever the second column is, or the B value. That's the second column. And this answer will give you the third column. Again, we've done this many times in class. Okay, this is your C value. We've done this many times in class. This is just a reiteration. If you need more help, make sure you ask, please. Okay, all the commands are listed here, step by step, on how to do this. The final thing is a unit converter. There are many ways to convert things in the SAT. Now, we've done dimensional analysis, so we've talked about conversion techniques, but what I suggest to you guys is to use the unit converter as much as you can. Only reason I'm telling you this is because it avoids any simple errors. It does take a little while to use it, though. So if you're only converting like feet to inches, just please multiply by 12, because there's 12 inches in a foot. But if you're converting something like feet to centimeter, and let's say you're given the conversion factor, in case you're wondering, 2.54 centimeters is equivalent to 1 inch, and you say to yourself, oh gosh, how do I go then from feet to centimeter? I have to do several conversions. And we've done that in class, but it might take you a little while. Say you want to save some time, use the APS command. So let's go ahead and do that. Again, we're converting 24 feet to centimeters. Bring up your calculator to clear my home page. Go to apps. Apps is next to math right here. So I hit apps next. I go down. I want to use the scientific tools, which are unit converters. So I have to go to sci tools. I would normally go all the way down to sci tools. I'm going to go up instead. Oh, come on, up isn't working. Let's try a command. Oh, there it goes. Okay. If I press up, I'm going to see that it's quicker to get the sci tools. Now I can do sci tools in French, in Spanish, or in English. I'll choose English today. If you want to try in Spanish or French, go ahead. But again, sci tools is the command I want. Once I open sci tools, it opens up this scientific tools, and it says press a key. So press any key. Now, you're going to see you have 4 options. You have a significant figure calculator, not used in the SAT. Ignore it, please. You have a unit converter, is used. Data or graph wizard, not as much, and then a vector calculator. The important parts right now are really the unit converter. So go down, hit number 2, please. Now, we want to convert, again, let's go back and look at our problem. We want to convert 24 feet to centimeters. feet are a length, so I'm on number 1. So I know I'm going to use length. If I was not choosing length, if I was converting a volume, if I was converting an area, say I wanted to convert from square miles to square feet, I can use the area conversion. So your units are very, very important. Again, notice this is a length because it's 24 feet, not feet squared. Feet squared would be an area. So I want to convert a length, so hit enter on length. Now, type in the number you want to convert. So the conversion is 24, and I want to convert from feet. So feet, where do you see feet? Well, according to this, feet looks like it appears right there. So go over until you get to feet and hit enter. So I'm converting 24 feet. Now notice right away, you typed in 24, but this says 2.4 e to the 1. Scientific notation. E to the 1 means 2.4 times 10 to the 1. Well, times 10 to the 1 really means move it over 1 spot. So that's where the 24 comes about. Again, when you see e to the 1, it means move the decimal over 1 spot. If you see e to the 2, move it over 2 spots, and so forth. So the calculator always does it in scientific notation. Now, so this is 24 feet, and I want to convert to centimeters. So at this point, just press the up arrow key to centimeters, hit enter, and there's your conversion. Now, a lot of people say, okay, yeah, my answer is 7.31 centimeters. Great, done. Use logic, use logic. 24 feet here. 24 feet, think about that length. Is that the same thing as 7 centimeters? It's not even close. If 24 feet were maybe the distance across the classroom, this is what 7 centimeters looks like. Those are not the same. So clearly there's a problem. Well, here it is, E2. E2 means times 10 to the 2. So this is really 7.315 times 10 to the 2. Or, if we remember, we move over 2 spots, which is 731.5 centimeters. So there's my answer, 731, which makes sense. 24 feet, 730 centimeters, reasonable answers. Okay, let's go back again, finally check our answer we got, and yes, 731.52 centimeters. Please fiddle around with all of these things we've gone over. Try more examples. Try different programs. Do them over and over again. Do them on your own, please. Okay, with that said, let's move on to strategies. That was just a brief overview of things you can do on the calculator. There is a lot more you can use the calculator for, and we'll come up with those as we go through some of the problems later. So again, for today, if we look at our syllabus, we are only looking at a calc lesson and strategies. And notice, guys, today is a longer lesson. We're already at about an hour, and that was only calculator. So we're going to spend not too much time with strategies, but we're going to go over some general ones to start. Now, your homework tonight will be based off some of these strategies. The first thing we want to do is take a look and say to ourselves, okay, we want to always get as many problems correct while getting as many incorrect, or while not getting any incorrect. So you don't want errors, but you want to get them correct. Because again, remember, if you get an error, then you have to think about it. Okay, well, the error takes off points. Every time you get something wrong, you get a negative score. Remember, it deducts a quarter of a point for each incorrect multiple choice. Not graded, but multiple choice. So when we're taking a look at this scheme, we want to think to ourselves, okay, what is my desired score here? If in a perfect world you got none wrong, and you answered only questions that you knew you got right. So let's say you answered 8 out of 20 in the first section, only 6 out of 18, and then you only answered 4 in the last section. But you got every one of them right. That's 8 plus 6 plus 4, which is 18 points. Well, that's 18 out of 54. And 18 out of 54 is approximately a 400 on the SAT. Okay? If you want to continue down, you can take a look. Say you're shooting for a 600. That means you need to get about 14 right here, 13 right here, and 12 right here, giving you a total of 39. That's assuming you get none wrong. So if you have to consider the fact that you might get some wrong, maybe you want to get like 15 correct and only 1 wrong there. And you might need like 14 correct there. So this would give you a 39 out of 54, which gives you a 600 as a score. So use this table to give yourself a general idea of where you need to be. Next, remember in the math section, there are 3 sections. 20 questions, 18, and 16. So let's take a look at this now. Again, we're going to see here, there are 20 multiple choice. There are 20 in a row. They start easy. You might have 7 easy. You might have 7 medium, and then maybe 6 difficult. Then you're going to have 16 multiple choice. In the 16 multiple choice, you might have, in this case, let's say 6 easy, 6 medium, and 4 difficult. There's your ones for 16 multiple choice. Remember, it always goes from easy to medium to difficult. Every one of these increases easy, medium, difficult. Now, the exception here, the exception is the multiple choice grid-in. The multiple choice grid-in, you start with 8 multiple choice. And those questions range from easy to difficult, between those alone. So you might have 3 easy, 3 medium, and 2 difficult. And then you're done with the multiple choice part. But then what happens is when you get to the grid-in, it starts over. So this might be 4, 3, 3. So again, you still have 20 questions, or 18 questions total. Okay? The first 8 of them are multiple choice. The next 10 of them are grid-in. So the section, even though it's one section, is pretty much broken up into 2 sections. You have a subsection. The first subsection is multiple choice, ranging from easy to difficult. The second subsection is grid-in, ranging from easy to difficult. So if you want to consider spacing this out as far as time is considered, you might not want to do these in the beginning. You might want to do the first 3 easy, the next 3 that are medium, and then jump to the grid-in to do those easy and those medium. And take a look. Even if you don't get to the difficult, you still did 13 problems on here. 13 problems on this mixed section with 18 problems. If you get 13 right, I mean, for 18 problem section, 13 right is right here. So you're looking at a 1600 without even looking at the hard problems. I'm sorry, not a 1600. I apologize. A 600. A 600 out of 800. Without even looking at the actual difficult problems, you can still guarantee yourself pretty much a 600. Assuming, of course, that you get all those right, which is the hardest part, assuming that you get them all right. Continuing. Work with the answers. If you have a multiple choice, there are times where you might want to plug them in. So please try that. Try plugging them in. If the multiple choice don't seem to work, or the multiple choice are variables, so let's say the multiple choice answers. So A, B, C, D, and E. Let's say the multiple choices are 2x, 3x, 4x, negative 2x, and x squared. And you somehow, let's say the problem in the beginning was to simplify. And the problem said, what is the value of 8x squared plus 2x all over 4x plus 1. And it says simplify. Well, you might get confused right away and not how to simplify. But the simplest way to do this is to factor out a GCF. So the numerator can become 2x times 4x plus 1 all over 4x plus 1. And what you'll notice is, oh yeah, sure, 4x plus 1's cancel, my answer is 2x. So the answer is A. But let's say you forgot, or you didn't know how to do that. You drew a blank there. You can always pick a value for x and then try it. So for example, if you pick x to be 1, which is the easiest thing always to try, okay, pick x equals 1. You're going to get 8 here, because 8 times 1 is 8, plus 2, all over 4 times 1 is 4, plus 1 is 5. If you pick x equals 1, 8 plus 2 is 10. 10 divided by 5 is 2. So if x equals 1, you get a 2. Well, in these choices, you can plug in a 1 for all these. Which one of these are you going to get a 2 as an answer? Only choice A. Again, plug in a 1 here, you get 3. That's not it. You get 4. You get negative 2. You get positive 1. So again, if you plug in a 1 for x here, here, and here in the problem, and you get 2 in the problem, then plug in the 1 in the choices and see which one of them gives you 2 in the choices. That's always a way to plug in real numbers, assuming the answers are variables. Next, the third one. Please don't take a wild guess, especially on the multiple choice. You have to have an educated guess. Only, as I said last time, if you can eliminate at least 2 or 3 of them, that's when you want to be guessing. If you can only eliminate one choice, do not guess. Next, connect what is being given to what is being asked. For example, if you're given 2 angles of a triangle and they're asking for the third, connect them. Well, if you're given that one angle is 30 and the next angle is 70, and they say find the third angle, okay, well we know the sum of the angles of a triangle is 180, so 30 degrees plus 70 degrees plus some other angle, call it A, angle A equals 180. Okay, well this is 100 plus A equals 180. subtract 100 from both sides, it turns out that A is 80 degrees. So you connect what you are given to what is being asked. How do you connect that? With the means of an equation. Okay, with the means of an equation. So always connect what you have to what you're actually being asked. Now, this next one is so important. Before you mark your answer, make sure you're answering the question being asked. Again, answer the question being asked. The problem might say, find the radius. And you do all this crazy work. And the diagram lists this as a diameter. You do all this math. Maybe it's like, you have a square around it. It's inscribed. You, in the end, solve for D. And you get D equals 10. You're like, finally, 10. Oh, look at that. Choice A is 10. Let me go ahead and bubble in choice A. But the problem said find the radius. Oh my gosh. Well, you know what? The answer must be 5 then. So go ahead and plug in the 5. Again, if the diameter is 10, the radius is half the diameter, so the radius is 5. Be careful. Just because you solve for D in the middle of the problem does not mean that they're asking for the diameter. In this problem, they might be asking for the radius. Same goes for x's. If you solve a whole problem and it says, and you get the answer as x equals 7. But the problem says, what is the value of 3x? Well, 3x is just 21. Please, just triple. And your answer would be 21. Answer the question being asked. Next, geometry specifically here. If you have a geometry problem, please draw a figure if it's not given to you. Simple as that. So if you have a problem where it asks for the area, and it asks for the area of the shaded region, so it has a problem like this, where you have a semicircle here, and another semicircle here, and let's say that they happen to be touching. That's a terrible image, Mr. Hell, I know that, sorry. Semicircle there, and they're touching at the middle like that, and the shaded region happens to be this shaded region. Well, to me, here's what I see. I see that if I want to find the shaded region, it's really a rectangle minusing off a semicircle like this and another semicircle like this. Again, I have a rectangle minus off the two semicircles. So that's what I mean by draw a diagram. If you're not given a diagram at all, and the problem says like, the length of the shadow of a person is this length, and the angle is this, well then you have to say, here's the person. Oops. The person is jumping up and down, sorry. Here's the person standing here, and say the sun is here, and it says something about the shadow, so there's your shadow. Here's the shadow of the person at the bottom. Here's your angle theta. That's your angle of inclination, or the angle that you're looking at the sun with. If they give you the shadow length, and they say like, okay, the shadow length is 10, and they say theta is 60, well, this is a right angle. Now you've got a triangle, and your triangle simply looks like this. It's a 30, 60, 90 right triangle. And from 30, 60, 90 right triangles, we can deduce the length of each side. Okay, that's where you're going to come into your 30, 60, 90. But again, draw a triangle. Draw your example. If a geometry problem contains algebraic terms, make an equation. For example, if you're given a triangle like this, and it says that the ratio of the length to the base to the height is 2 to 7. Well, that means you have 2x is the base, 7x is the height. And then it tells you the area is 2,000. Okay, area of a triangle equals 1/2 base times height. So 2,000, which is the area, equals 1/2 times the base times the height. All right, great. So again, I solve for x, I get a value for x. So let's say we get an answer for x here. Solving for our answer, we can 1/2 from that, just divide by 7, take the square root. The answer is going to be 2,000, oops. Let's keep putting out of here. It's going to be 2,000 divided by 7, and then we want to do the square root, second answer of that number. So 16.9 turns out to be what x is. So, going back to this problem, again, we have 2x, we have 7x, we have a right angle. We're told that 2,000, again, the area of the triangle, is equal to 1/2 base times height. This is 1/2, 2x times 7x. Again, it turned out for this problem that we got for our x value 16.9. So x is simply 16.9 here. Now, the problem's not done. If this problem, again, said find the length of the height, or find the length of the base, you got to take this and plug it in there. Take 7 times that number, that'll give you the height. or take 2 times that number, that'll give you the base. Okay, remember to plug in your number at the end. Almost done. Next, the figures that are drawn are accurate unless they are noted otherwise. So if it looks like 2 lines of the same length, then there's a good chance they're the same length. A lot of the figures, though, say not drawn to scale. If it says they're not drawn to scale, okay, if it says they're not drawn to scale, do not make any assumptions based on the figure alone. I recommend that you redraw that figure. Redraw the figure so that it is drawn to scale. There was a problem that I worked on, I remember 2 years ago, where it said that angle ABC is 90 degrees. And the figure looked like this. It was so misleading. We looked at an example of a triangle like this. And this was A, this was B, this was C over here, this was D. And it said ABC is 90. Well, take a look. ABC is that angle. And that doesn't look like 90 to me. To me, it looks like this is 90. But it said at the bottom, figure not drawn to scale. So you cannot assume, because it says that it's not going to be drawn to scale. So make sure you check what the problem says. Next, in your booklet, make sure you mark the numbers down. That's common sense. Again, guys, mark the questions down in the booklet, so in case you skip, you don't skip to on the test. So many students, I've seen this before, they're bubbling their answers, they're bubbling it in, and then they skip number 5. Okay, so they should go to number 6 and leave a blank where number 5 is, and come back to it. But you know what? Some people forget to skip number 5, and they put their answer for number 6 and number 5. And then everything's off by 1. You can't go back after the test and fix it. They will not let you go back. Again, you have the time allotted. If you make a mistake like that, it's a waste of your time. You have to go back and correct it. Let's see. Finally, grid-ins. Again, grid-ins, we talked about this last class, so I'm not going to iterate them so many times. Can't be negative or greater than this number. If you have a hunch, take a guess. Okay? If you don't have any idea, again, try 0 or 1 as your answer. If you have no clue whatsoever. If you have any hunch, take a guess. You can't lose points on a grid-in. The next, and one of the biggest things here on this test, do not read the directions. I know that sounds crazy. Be familiar with the directions. You should have taken by now, at the end of this exam, or at the end of the SAT class, at least 10 practice sections. The directions are the same every time. Read them when you're practicing, but on the test, do not read them. This is the only time I'll ever tell you not to read directions, because you should be so familiar with them that they're practically memorized. Okay? They're practically memorized. And again, remember, do not spend 5 minutes on a question. You're looking at a little bit more than a minute per question. If you're 3 minutes in and you have no idea still, please move on. You need to get as many of the questions correct with as few of them incorrect. That's always the goal every time. Again, remember tonight or this week, your assignment this week is to go ahead, complete the calculator lesson worksheet. You'll see that. I'll put the answer to that up on Friday. Complete the practice section 2, and then complete the strategy sample questions, pages 1 through 3, and you'll see the answers on 9 through 11. Remember that last week you were supposed to complete these 4 portions. This you're doing on your own. The answers are there for you already. If you look at the answers, this is just a read through. This you should have completed, and you'll see that under the homework now, there is a solution to this. Go ahead and take a look at it when you get a chance. You'll see it's a very detailed solution, all handwritten. Please look at it and check with your answers. So again, this week you'll have 1, 2, 3 documents under homework. On Friday, I will put the solution for this and the solution for this under homework as well. The solution for the middle one is on pages 9 to 11. Again, any questions this week, please bring in any questions to any teachers, Mr. Malchek, Ms. Solstice, Mr. Smith, or myself, Mr. Howell. Have a great week and good luck with your work.